Okay, so 14.1, so limits. So connection between algebra, geometry, and then the stuff you'll learn hopefully next year, well, in calculus, which most of you probably go on. So here's the notation that deals with limits. So this says the limit of the function f of x as x approaches c equals n. Okay, other ways of interpreting this are, so what does that really mean? Anybody have a clue what that means? Sorry, repeat that?
The closer the x gets to c, the function is closer to n.
Yeah, that's a good way of looking at it. Alright, let me find my notes. So that one, right? Or that one. That's like even more plain language. So we're just trying to see, hey, what happens to a function when we stick in a number that is close to c. Right. So this definition says nothing about having to be defined at c, or for that matter, to have a limit. So what I'm trying to say is that to have a limit, you don't have to have a function that's defined at the point that you're interested in. And often, actually, it's because we're not sure what happens there, because we don't have a defined function. That's why we're going to take a limit. So there are different ways that you can get a limit. You can get a limit sometimes by using tables. And then, if you're using a table, all you do is find numbers that are closer and closer to the value that you're interested in. So in this case, we want to get close to 2, right? So I could clearly plug some of this stuff in the calculator and figure out what happens here at 2. Well, so what happens when you plug in 1.9? So if you have a calculator, you can sort of follow along. But these are the numbers that you would get if you use a calculator and plugged it in. And you can either do it one by one, or you can plug it into the calculator and use the table set function if you have a graphing calculator like a TI-84, and then that would be a little bit faster because you don't have to keep plugging in the values. So this is what you get. So apparently when you're close to 2, this function is what? What's this limit? 4, right? Okay. As we also saw in the bell work, you probably could get there a little bit easier, right? Because x squared minus 4 is x minus 2 times x plus 2. Yes? So that when you factor the undefined value out, you're just left with x plus 2. And then when you make x equal to 2, you get 2 plus 2 is 4. Okay. Now you're probably wondering, well, why even use a table if you can just do that all the time? Well, can you do that here? Can I factor out this x? No, right? It's not like I can just divide it out somehow, and there's no way to factor the top. So how can you find the limit here? Well, there are algebraic techniques. This would be one of them. So if you can factor, get rid of it, and then plug in the value, then that usually works. But in this case, that's not even possible. So what are we interested in? Well, we're interested in values close to 0. So give me a value that's really close to 0. What did you say? 0.01. Okay? And we will use that. .01, and when you plug that value in, you get 99998. Okay. Now usually we do want to sort of see the progression. Like in this case, I don't think I need 6. A lot of times you don't need 6. So, but here you would get 99833. But it is important to check on both sides. Now in this case, we do get symmetry here. So these values just sort of repeat. That's not necessary either. I don't know if I have an example of it in the notes, but I know in the textbook assignment you need to check on both sides, because this is not always going to happen. So in this case, what does your limit go to? Yeah, this thing is going to go to 1 somehow. Okay? You guys okay with that? Just by looking at the table, right? Alright, let's look at, so this is based on tables. So on tables it's really not that hard. You just use your calculator, plug stuff in and see what happens. You can also find a limit by graphing a function. So this one says find the limit when x goes to 0, and then the functions, this is called what kind of a function again? Yeah, this is a piecewise, right? And that's why this one does have a connection to why would we talk about limits, and then this one. So let's just graph what we're given. So 5x minus 1, that starts here, right? The first one. And then you go up 1, 2, 3, 4, 5, and over 1. So there's a dot there, and down 1, 2, 3, 4, 5. To make sure I mark that. So 1, 2, 3, 4, 5, down, and then over 1. Okay. And then, how do I graph this? When x is 0, what should I mark on my line? Yeah, so we're actually going to use that open circle. So I guess I sort of was lucky that I drew it semi-open. So then you get this line. I have to do the dotted so I can get a semi-straight line here. There's no way for me. And even with that, wow, that's bad. Okay, and then what value is this function worth at 0? 0, right? That's what it says. So what's the limit here? What is the limit of this function when x approaches 0? It's a -1. Why is it a -1? Why is it not 0? And to me it centers on, and I did say it right here, I said x does what? X approaches 0. So it's not equal to 0. When x approaches 0, what happens? Well, when you're on the graph here, you end up over here, right? So that's value slightly less than 0. When you're on the other side of the graph, so when you're coming from the positive direction, you also end up in this spot. So what must the function be worth when x approaches 0? It has to be that -1. So even though the function's defined at 0, it's 0 at 0, even though it's defined at 0 to be 0, the limit here is going to be a -1. Are you guys okay with that? Okay, and this is sort of the key point here that I'm trying to make, is you have to look both from the left and from the right. We call it from the left and the right. The left would be numbers less than what we're interested in. Does that make sense? And from the right means we're looking at numbers that are more than what we're interested in. Alright, 3 cases where the limit for each graph is the same, yet the graphs are not identical. And you already have the graphs, so might as well put them up. So, what happens here? Well, this is a continuous function, right? So the limit of the function really here is going to be that point. Does that make sense? So this function is defined at this point, and at that point the limit is what the function is worth. Okay, then here we have, basically we have another example of what I just showed you, right? Just now with curves. So here the function moves from the left, it moves towards this point. At C it's worth this much, but then when you come from the right, it moves towards that point. So your limit here is what? Yeah, it's this point here, right? Okay? Your function's limit is going to be towards here. The function's still defined, but it's defined in a different point than on the continuous function. Okay, and here we don't even have C. C is not defined at all, right? C is not defined at all, because I'm looking at C and there's not a dot above it or below it. But, yes?
For the left one, would that be like a cube root of x, or would that have to be
Like this one?
Yeah.
Here?
Would that have to be two separate ones?
Well, we don't know what the rest of the function does. I mean, I could make it a sine or a cosine. So I don't know. It could be a lot of stuff at this point, right? I don't think you have enough information to answer that. I think your cube root guess is possible, although the cube root, if this had been the shape, I would have expected it to do more of this. Does that make sense?
Yeah.
Okay. So here, function's not defined at all, but as you approach C, from the left and from the right, you are still going to be at this point. We're still okay with that? Alright. And then the last one here is so that you understand that there is more in this world of limits other than what you have seen so far. So x squared, if x is greater than or equal to 0. Greater than or equal to 0. So I can start here, right? And then x squared would look like this. You okay with that? And it says if x is less than 0, then I'm just worth a -2. So at less than 0, you have an open circle, and you would move towards the left only at a -2. Are you guys good with the picture? Okay, what's the limit? As x approaches 0, what's the limit for this function? -2? Why? Because you're coming from the left and you're approaching and you're at a -2? But what happens when you come from the right, when you come from above? What value are you approaching? Okay, and then this is how you can write that. This is the limit of x approaching 0 from the left, and you guys are telling me that the function's worth a -2, so this is from the left. You okay with that? And then here, this is the limit as x approaches 0 from the right, and the function is worth what? 0, and since these two are not the same, we're going to say what? Undefined? Or does not exist? Does that make sense? The limit only works if both from the left and the right we are heading towards the same number. Because if you tell me, like Chris, when he said -2, there's nothing wrong with what he said -2, but then when I'm going to ask him, well, I'm coming from the right and I'm coming at 0. What if we're supposed to meet? What if you're supposed to meet your friend in town and you come from the left and you end up at intersection A and I end up at intersection B? Are we ever going to meet? How do we know where we're supposed to meet? Well, you don't. So the limit in this case just does not exist.